Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to learn about the instrumentation of NMR instrument. Okay, how the NMR instrument works and the applications of the NMR spectroscopy. Okay, so let us first start with the image. So this is how a NMR instrument looks like. Okay, so what are the basic components of any NMR instrument? So there is a superconducting magnet. As in the last video of the basic principles, we had seen that we subject the sample in a magnetic field. Okay, and how do you provide the magnetic field? With the help of a superconducting magnet. And there is another thing, there is a RF radiation, okay, or radio frequency transmitter is present. Radio frequency or RF transmitter is present. Where that RF transmitter is present? Okay, the RF transmitter is present in an instrument called as NMR console. Okay, this has the NMR RF or radio frequency transmitter, and several other hardware applications is present in the NMR console. Okay, and inside the superconducting magnet, what is present? There is a sample holder, okay, where we place the sample tube. Okay, the first thing is we dissolve the sample in a solvent in a thin NMR tube. Okay, there is one NMR tube that is used for preparing the sample. We'll see in a minute how the sample is prepared and how everything takes place. So from the NMR console, there is RF transmitter, and then that is connected to a workstation, that is the computer, okay, or called as the output, okay, where you will get the NMR spectrum. Okay, when you can see the NMR spectrum, and then you can do the analysis to find out, or to do the qualitative analysis. Okay, qualitative analysis means to know the structure of the unknown compound or unknown sample. Okay, you do the qualitative analysis, okay, with the help of the NMR spectrum. This is the basic idea of the NMR instrument. There is a superconducting magnet. Inside that there is a sample holder where you keep the NMR tube, and that NMR tube, this is the NMR tube that you can see here. Okay, NMR tube that has the sample. Okay, here you fill your sample, and that NMR tube is kept inside this superconducting magnet. So in the presence of magnetic field and the radio frequency that is emitted from the NMR console, and after doing the amplification of the signal with the help of the amplifier, okay, you get the output. Okay, with the help of the detector, the signal is detected and you can see the NMR spectrum. So talking about the block diagram, again, see there is a sample tube, okay, that is subjected to the magnetic field with the help of a superconducting magnet. Okay, plus there is a RF transmitter. Where is this present? It is present in the NMR console. Okay, and then as we saw the principle, there will be spin flipping. Okay, flipping from alpha to beta state. Okay, there will be spin flipping of the nucleus. Okay, that is resonance will take place, and then when this nuclei, okay, when it spin flips from alpha state to beta state, okay, and then this beta will come, okay, it will again undergo spin flipping to come back to the alpha state. That process from beta to alpha, that is called as the relaxation. Okay, relaxation, that is change of spin of the nuclei. This is also called as flipping. Okay, spin flip. This is also called as spin flip. Okay, so after relaxation, that signal is detected by the detector, and then there is an amplifier that will amplify the signal or increase the intensity of the signal. Increase the intensity of the signal. Okay, detector, amplifier, and then there is something called as FT, okay, Fourier transform. We'll see this in detail in the next video. What is Fourier transform? Okay, I'll give you a short idea of what is Fourier transform in the coming slide. Okay, after Fourier transform, you get the NMR spectrum. Okay, so the very first thing that you have to do is you have to prepare the NMR sample. Okay, so for preparing the NMR sample, what all things you need? You require obviously your sample, okay, or the compound that you want to analyze, some sample or the compound that you want to analyze. Okay, so basically when you do, mostly when you work in the field of organic synthesis, the thing is that the first thing that you have to keep in mind is that your sample, when you do the NMR analysis, when you do take the NMR of the sample, when you complete the column chromatography. Okay, first you do the separation and then you do the analysis. So the thing is that before you do the NMR, the very important thing is that you apply the high vacuum. Okay, apply the high vacuum in the rotary evaporator. Okay, rotary evaporator that you use, you first apply the high vacuum. Okay, and then you dissolve your sample in the deuterated solvent. Okay, like the most commonly used solvent is CdCl3 or deuterated chloroform. Normal chloroform is CHCl3. Deuterated means hydrogen is replaced by deuterium. Okay, so why do you apply high vacuum? Suppose your sample was you used during column chromatography, suppose you used ethyl acetate. Okay, but in your spectrum final data you don't want the ethyl acetate or whatever solvent you were using for column chromatography. So that is why first you apply high vacuum, then you dissolve your sample in the suitable deuterated solvent CdCl3. Okay, why you don't use protonated solvent? Because this H will also show peak in the NMR spectrum and you don't want that. Okay, you want only the peaks of the sample or the compound. Okay, you dissolve it in the CdCl3 or suitable solvent. So this is the sample. Okay, you dissolve it in CdCl3 and then you add it to this. This is called as the NMR tube. This is called as the NMR tube. Okay, then how do you transfer the sample? Okay, using this instrument, this is called as the micro pipette. Okay, so this is basically, its working is similar to like a dropper. Okay, a glass dropper. How do you use a dropper? First you press. Okay, press the bulb. Okay, this is the, let's say this is a dropper. Okay, first you will press the rubber bulb. Similarly here there is one knob that you have to press. Okay, and then you dip it in your, okay, you dip it in your sample. Okay, the next thing is you dip it in your sample and then you, here first you, what you have to do, you have to press the knob and then you dip it and then you release it. Okay, as soon as you release, this will, your compound will go into this NMR tip. Okay, this is called as the NMR tip, or you can say micro pipette tip. Okay, in this micro pipette, here there is some readings, okay, that you can set. Okay, how much volume you want, readings for the volume of the sample or the liquid that you want to withdraw. Okay, that you can set. Okay, and then you keep the NMR tube in the, okay, this is the NMR tube holder. Okay, and suppose this is a cap and this is the NMR tube. So how much sample you have to fill? Okay, there is one level of, desired level of solvent that is recommended. Okay, it should not be less than that. So what is the recommended amount of solvent that you have to use? So CdCl3, the recommended amount that you must use is 0.5 ml. Okay, if it is slightly more than that, that will be loss of your CdCl3 or the deuterated solvent. Okay, the deuterated solvents are comparatively costly as compared to the normal solvent. So the minimum amount should be what? It should be 0.5 ml. Okay, it should not be less than that. Okay, 0.5 ml is more than enough. Okay, so you add 0.5 ml into your compound that you want to analyze, you dissolve it in the in CdCl3, then you transfer it to the NMR tube using a micro pipette. okay, using a micropipette, and then you keep the NMR tube in the NMR holder. Okay, the next thing is you have to load this sample into the NMR machine. Okay, so how do you do that? Loading the sample in the NMR machine. How do you do that? For that, again, you want the NMR sample. Okay, the NMR tube that you have, you need the NMR tube that contains the sample that you want to analyze. Okay, then you require this instrument. This is called as a depth gauge. Okay, depth gauge. Okay, what is the role of this depth gauge? It will insert or your NMR uh, tube. Okay, it will insert your NMR tube at a appropriate height. Okay, appropriate height. Okay, appropriate height into the NMR machine. Okay, and this is called as the spinner. Okay, so this NMR tube you will first insert with the help of this spinner. You will insert it into the depth gauge. Okay, with first you take the NMR tube, you put it into the spinner, and then you, with the help of the spinner, you insert your tube into the depth gauge so that a certain height of the compound, okay, it should not be too low, it should not be too high, otherwise the scanning or the shimming will not be proper. All these terms we'll learn in the next video, what is the meaning of all these terms. Okay, so this is the level. Okay, this is the minimum level of solvent that should be there. You can see the level of the solvent is more than what is desired. So this is the correct NMR sample preparation. Suppose the level of your liquid is less than the indicated mark, then that is not correct. Okay, then the scanning will not be proper and you will not get the proper peaks in the NMR spectrum. Okay, now this is ready for putting into the NMR machine. Okay, so now this is the automated machine. Okay, there are two types of NMR machines. One is the automated version where these are the sample holders. Okay, these are the different sample holders that you can see here. Okay, just you have to keep your NMR sample with this spinner into the holders. You can see these numbers. Okay, you have to give command in the computer accordingly in which sample holder number you have kept your sample. Okay, accordingly you have to give the commands and it will automatically pick up and scan. Okay, there is another machine that is called as a manually operated NMR. Okay, where you have to manually take this sample and load it directly into the magnet or the machine that I had shown in the first slide. Okay, so how it works? So basically, first, as I told you, first you dissolve your sample in the CDCl3 and place it in the NMR tube. Then see, this is the manually operated version. Okay, you directly load it into the superconducting magnet. So here there is a place where you can keep the NMR tube along with the spinner. Okay, insert the NMR tube into the vertical cavity of the magnet or bore of the magnet. Third thing that you do is you subject the NMR tube to two things. One is the radio frequency and another is the magnetic field. Okay, there are two things that are working. Okay, so bore of the magnet consists of a probe, okay, that has a transmitter of RF. Okay, there is RF pulses that is subjected to the sample. Okay, and then this transmitter, as I told you, it is present where? It is present in the NMR console. Okay, along with the other electronic equipment. Okay, so after you subject it to the RF or radio frequency and magnetic field, what happens? The next thing is a short intense RF pulse. Okay, after you load the sample, what will happen? There is a intense radio frequency pulse that is sent from the RF transmitter from the NMR console. Okay, from the NMR console there is a radio frequency pulse that is sent to the probe. Okay, probe that is surrounding your sample. Okay, so here you can see this is the probe which contains your NMR sample. Okay, then there is absorption of the RF frequency, and then there will be spin flipping, that is a change of the magnetic vector of the nuclei. Okay, whatever nuclei you are scanning, that will absorb the radio frequency. There will be resonance. Okay, in the presence of magnetic field there will be resonance, and then a plot is generated. Okay, the fifth thing is, what happens is the magnetic field associated to the new orientation of the nuclei. Okay, initially all the nuclei are oriented in one direction. When you apply the magnetic field, some are in the alpha state, some are in the beta state. So based on the relaxation, okay, the nuclei will relax rapidly at different rate. Okay, different rate based on the different chemical environment. Okay, this we'll see in the next video, what is the meaning of different chemical environment. Okay, and as the magnetic field changes, there is an electrical impulse that is generated. Okay, there is electrical impulse that is transmitted from the probe to the receiver in the console. Okay, as a form of a free induction decay. Okay, this plot you can see, this is called as the free induction decay. Okay, the receiver will receive the electrical impulse after the NMR nuclei undergo relaxation or spin flipping. Okay, after spin flipping, or we can say resonance, what will happen? A free induction decay or FID graph will be generated. This is a plot of amplitude versus time. Okay, so can you analyze from this? The answer is no. After this, what you do, you apply a function that is called as Fourier transform. Okay, it is a mathematical function. Okay, you apply the Fourier transform. Okay, the sixth thing is, sixth one is the pulse relax sequence is repeated, that is change of spin from alpha to beta, and then beta back to the ground state, that is alpha. Okay, so this pulse relax sequence is repeated many times, and the free induction data is stored in the console. Okay, the FID is stored in the console. Then from console you want your data to the workstation, right? Workstation means the computer that you are working on. Okay, so you transfer the data from the NMR console to the computer. Okay, that is, you will, the mathematical function called as the, let me clear this, mathematical function called as the Fourier transform or FT is carried out by the computer, that converts the amplitude versus time, that is the FID, okay, FID or free induction decay, to this spectrum. What is the NMR spectrum? It is a plot of amplitude or the intensity, okay, amplitude or intensity versus the chemical shift, okay, or the frequency, which is unit of this is hertz. Okay, ppm, you can convert ppm to hertz, vice versa. You can see the spectrum in both the units, either hertz or ppm, parts per million. Okay, displays the resulting spectrum on the computer. Okay, so I hope you have understood the entire principle. Okay, the instrumentation, what are the basic components, how the NMR instrument works, how you first prepare the NMR sample, how you load into the NMR machine, and after you load into the NMR machine, what exactly happens, all the steps. I hope you have understood that. Now the last thing is the application. What are the application or use of the NMR spectroscopy or the NMR instrument? The most important use in medical industry of the NMR is magnetic resonance imaging. Okay, magnetic resonance imaging. So I'm sure some or the other time you might have done an MRI, okay, or you might have at least seen the MRI machine in the hospital. Okay, so this is the MRI machine. So this is a bed where the patient will lie, and this entire thing will go inside this round thing. This is what this is a highly, okay, this is a superconducting magnet. Okay, just now we saw in an NMR machine also there is a superconducting magnet, so it keeps on rotating, okay, rotating. And what it will do is, the main use of this is the diagnosis, okay, or the diagnostic features. It will show you if any disease or ailment is present in the patient or not. Okay, it will provide certain images of the internal organs. Okay, it will provide the images of the internal organs. So basically the human body is subjected to the magnetic field. A very high strong superconducting magnet is used for that. Based on the same principle, the images are generated, okay, and that are analyzed to find out whether a person is having some disease or not. Okay, that is for the diagnostic tool. Okay, there are several other applications of NMR, like in chemical synthesis or reaction monitoring. So in organic synthesis, basically you use the NMR machine to analyze the compounds, okay, to analyze the natural products that you synthesize, or the intermediate compound that you synthesize. The structure of that molecule you can do using the NMR machine. It is a very important application of the NMR machine. Another application is molecular imaging, then metabolic profiling. Then you can analyze the molecular structure and the dynamics, okay, of several naturally occurring as well as biomolecules like amino acids, nucleic acids, proteins, peptides, complex structures of the proteins. Okay, all you can do with a single instrument, that is NMR. You can also analyze the molecular interaction. Then there is low throughput ligand screening, drug discovery, to analyze the structure of the drug that you have synthesized or discovered. That everything you can do using NMR. It is also useful in the field of agricultural, food industry, polymer and solid materials, okay, or solid state synthesis. Okay, so I hope you have understood what is a basic instrumentation of NMR, how does it work, how do you prepare the NMR sample, how do you load it in the NMR sample, how exactly the scanning takes place, how the data transfers, okay, once you load the NMR sample, from loading to getting your data in the computer screen, okay, how this process takes place. I hope you have understood that. And that's it for this video. In the next video, we will understand the technical terms related to the NMR spectroscopy, like chemical shift, what is de-shielding, shielding, downfield, upfield. Okay, how with the what is chemical shift and what are the factors that affect the chemical shift, and how the splitting takes place. Okay, how basically you do the structure determination. That is what we are going to see in the next coming videos. Okay, it is a very important synthetic tool. Okay, NMR instrument. Okay, and thank you. That's it for this video. In the next video, we'll see the basic theory and how do you exactly do the structure analysis or interpretation of the NMR spectrum, that we'll see. Thank you.